Hello and welcome to the 25th lecture of course on data-enabled tribological engineering from experiments to predictive model. We have learned many things in first 24 lectures. Let me summarize which is more important for this lecture. We say we have established initial knowledge base in tribology covering topics like friction, lubrication, wear, corrosion, coating, nanotribology. We've covered also a few examples to provide a thoughtful understanding of practical analysis of tripod systems. We understand also the friction and wear integrated process, and they depend on a specific parameter which are related to system. Further, to understand tribology in deeper way, we need to adopt two approaches. One is that deductive modeling, which we derive the relation directly from equations or from scientific laws. Second, which we are covering recently in these lectures, there's a data-driven modeling contribution which can be made, or maybe models can be made from a data which we get from experiments. We learn about the supervised learning or supervised machine learning, which closely matches the cognitive process of the human. Reason being, whatever the relation between teacher and student, same thing is established by the machine learning. Tutor imparts knowledge derived from available literature and instruct the student to solve a few exercise questions for which corrected answers are already provided to students. The students learn, evaluate the outcomes, and they compare with the provided answer. If our response is not correct, naturally student have to revise the complete syllabus or knowledge level and iterate it till it really acquire the complete knowledge which makes him suitable to appear for the exam. So same thing is processed or same thing is repeated in a machine learning. So what we say that similarly in supervised machine learning, training data set containing inputs and outputs or maybe corresponding correct outputs are provided to the algorithm. So here algorithm is a student, and then whatever the human who are providing input and output, corrected output to the algorithm, they become a tutor. And algorithms learns on, and in future whatever the data are provided to the algorithm predicts what will be the corrected answer. And this is all about this course. So what we learn also that we have a MATLAB tool which provides a very maybe some mini algorithm. So I can say the MATLAB toolbox, it has a several algorithms to experiment with a different ML model or machine learning models, and it should select the optimal one which is giving the best results. And if I see what are the algorithm, we already have covered this regression learner, which is still in this lecture also I'll try to explore more. We also have a classification learner. Now this, as per this topic, is a deep network designer, deep network quantizer, deep network net clustering, neural net fitting, neural net pattern recognition, neural net time series. So this indicates very clearly that recent time more and more algorithms are coming related to neural network. This is what initially we showed that MATLAB has supervised learning and unsupervised learning. Just classification and regression mostly come in a supervised learning. Of course, it can come under unsupervised also, and clustering. And then we explored few in the examples in this. We describe something in naive Bayes, and then we use also what the SVM. We learn something about the linear regression. So these are the things already available in a MATLAB. And in the present lecture, we are trying to give a little more emphasis on neural network because that's the future. Of course, it has also some limitation. Those limitations also will be highlighted in this lecture. So what we are saying in MATLAB, it has an inbuilt algorithm to partition the data. If you remember, we will say that whenever we are giving the data, we need to go ahead with the training set and we need to go with the test set or maybe say validation test. So MATLAB has an inbuilt algorithm which partition the data given to algorithm in training set and the testing set. This can be 70%, 30%, it can be 80%, 20%, it depends. We have a choice. So we set those things, and the model is trained based on the training data. We find out what is the really accuracy level so that overall algorithm is robust and it can predict the future. So there is some sort of comparison being given. So what we learned earlier, linear regression, and maybe somewhat regression trees are also there, which are linear in the nature. SVM, the support vector machines, for the linear, they are easy to interpret, but other algorithms are little difficult to interpret. MATLAB has algorithms, but when we try to interpret, it becomes a little difficult, and we need to go line by line, which we will be also covering in the present lecture. You look at SVM, whatever we learn, maybe say this year, if you look at the next year and next version of MATLAB, most of the algorithm will change. Here now, earlier we were talking about only linear SVM. Now they have come up with a quadratic, cubic, fine, medium, coarse, different maths, and then they have also comparison. If you want only SVM, so all comparison can be made in one go, and then also they can use some sort of optimization algorithm on SVM. We will learn also in this in this lecture what is optimization and how we should achieve that. As I mentioned, we will be giving little more emphasis on neural network. Why we are going to give? Because in this situation, governing equations are not available to us. Particularly in tribology, there are number of data available in the literature, or number of outputs are available in literature for the given inputs, but the relations are not well established. And then we use some sort of a coefficient, multiply coefficient, and one situation to other situation, that coefficient gets changed. Now we want to learn about those relations. Want to dig out those relations. So that's why we say analyze historical data and signals to create a prediction. So the maintenance cost can come down significantly. Breakage of the items can be reduced significantly. Energy can be saved by reducing the friction. Otherwise, we've been doing experiments. Naturally, we cannot do so many experiments. Whatever experiments we do, we don't get complete information, and because of the lack of information, friction is still dominated. Wear is still dominated, so we have friction losses, wear losses, and overall national losses. So these are the important, and then we want some sort of neural network algorithms to predict the relation, so that it can help in taking decision. So it adds a decision making. Now, why we have been giving more emphasis, why in the recent time the artificial neural network is getting more importance, reason being that it is not having any established relation. So it works on the trial error method. Now, when it works on the trial error method, it's a self-learning method. Even though many researchers, they oppose this, they say there is no science, it is just a trial error. This time it will give good result, maybe next time it will not give good results, possible. But how a human brain work, it is exactly the same way. So we get a census, and then based on that, and also we try to explore the knowledge, whatever knowledge we have, and we interpret the knowledge in our way. If we fail, we improve. So finally we try to dig out what are the concealing patterns in a whatever the information we are getting. So we infer, we try to take a decision based on that. That's a human brain works, and similarly artificial neural network works. It has a number of neurons, and then some data are being provided. It does some sort of activation on those data, try to find out some relation, iterate the relations, and come up with the right relation as such. So same thing what human being doing, neural network does the same manner. And I agree, it takes a trial error, uses a trial error approach, but overall results are favorable, and then it can be predicted. And we have famous examples of Alexa and then Netflix and Amazon, where they are trying to customize, and they are trying to understand or maybe to feel the human interaction also. So that is very important. Of course, we don't want to go to that deep level, because this will be called the deep neural network, and they take almost 140 layers also, and each layer has some processing. So we don't want to go to that level, but we will try to touch. I mean, MATLAB has already some sort of pre-trained algorithms, so we'll be describing to some extent those things. So what we, another additional thing is a neural network often, because it takes a many data, so it is able to remove the kind of noise. So if there is a slight fluctuation in a data, it doesn't really affect the neural network accuracy. However, when we understand everything properly, then it will happen. Otherwise, if we use as a layman neural network, it may not give a results, or maybe it gives results in one time, but it may not give results second time. So this is important. It is important to understand how overall system works, how we make it more useful for our purpose, for tribological purpose. So let me describe. We say often neural network and then made in a number of hidden layers, and we say if there is a one hidden layer in this case, and it has a 3 neurons. This there is another hidden layer. It has a 4 neurons. Why we are using the word hidden layer? Because it is not available to the outsider. Of course, when we are cycling a deep neural network and we want to explore the complete algorithm, it makes. Maybe Alexa has a many hidden layers which are not known to us, but in processing it may be utilized. So what are the in this neuron I'll be describing, and what we are saying, it is a name has been given as a hidden layer, reason being it is not approachable from outside the neural network. And final layer is known as the output layer. Input data has been given, then it will be known as the input layer. Now depends on number of neurons in each layer. The MATLAB divides a narrow network, medium network, wide network. What MATLAB does something like a 10 up to 10 neuron, they say narrow network, and then medium is up to 25 neurons, while wide can start with 100 also. So of course it is not a very strict, it is just numbers. If you give 20 neurons also in a medium layer, that's possible. We are able to change those number of the neurons. Now what is a neuron and what is importance? That has been shown here, that this is the same thing what I am showing here. One is the same thing over here. This is what we say in other languages. This is the kind of the note. It gets a number of inputs. X1 is input, X2 is input, X3 is input. Here we are shown 4 inputs, and here we are showing only 3 inputs. Right? And then every input goes with some sort of weighting factor. Now weighting factor can be decided by the algorithm itself. In addition, there is a possibility that input parameters are not affecting the node, it is something else is affecting, or it has some sort of residual maybe some effect, so that there is a bias. So B is also be a parameter which will be decided by a neural network. W1, W2, W3 will be decided. There may be direct output, or we get some output through activation function. What is the activation function? So here when we are saying that in your this is the 1, and output here we are writing a V1. V1 is a summation of W1 into X1, W2 and X2, W3, X3 and plus B, right. So this is a linear function, and often we require a non-linearity, and neural network has become famous because of the non-linearity. If we want a linear function, then there are several algorithms, but activation function which is incorporated in neural network, it provides a non-linearity. For that purpose, what we see then instead of directly y here, y is a function of v, and v is a linear function. Now this will be known as a activation function. There are several activation function in the literature. MATLAB uses 3 in the activation function, and 1/4 option gives a none. That means no use of activation function. So I have used a MATLAB, so I find out 4 options. One is a none and 3 other activation functions. Another the good knowledge is available. As I say, we will be trying to explore the literature. I find a few interesting points from this research publication, which was published in 2000, and what they are trying to give a basic concept of artificial neural network modeling and application. Of course, this is not related to us, but I find the language which has been utilized is very good. Now what they are saying, that it is not that ANN has started recently and become a popular. We have been also using some sort of expert systems. If you look at the 1990s, 1980s, we find a number of literature related to expert system. Our knowledge management, a special word was used, knowledge management. What was the difference that time? We used to have a firm rules, cannot be changed. and it was all everything was logical. It's something like a complete science has to be there, so logical concepts, and they will be following a sequential thing. After one first rule, then second rule, then third rule, then fourth rule. If you do not follow sequence, then you will not get a good results. So that's why we say these are the conventional computing system which we were earlier using. We have also developed expert system for coating selection, expert system for lubrication, expert system for the bearing selection, gear design. These are the systems are available. So what is in those expert system? We say conclusions are made based on a predefined set of the rules. So everything is well known to us. What we know in these days, many things are not known to us, and if we things are not known to us, how do we make rules? That's why we required ANN for these days. However, in expert system, we say they solve the difficulties by simulating logical thinking, by building the list of logical propositions and applying logical transformation to them. So everything was a logical, scientific manner, and it will be going systematic manner. However, Socratically, the Socrates was the philosopher, and his thinking was slightly different. We say it is a kind of perception, and then when we are bringing a perception, and then of course this paper gives an example of the pen. We say we have learned the pen, and whatever the shape of the pen comes, immediately it appears in our mind the pen. It may be something different, but analogy comes there. And we know very well, whenever we are going for innovation or creative thinking, we need to come with this kind of thinking. Things are not well known, we perceive, we think over, and then make those things. Not everything is already available in black and white, which was a major limitation of expert system. And often people use the word, oh, this is required for the left hand brain, this is required for right hand side of the brain. Right hand side brain is a creative, so if you want to do any creative work, go ahead with artificial neural network. That's a possible. So what we are saying, why do we require artificial neural network? We say conclusions are frequently hindered. Many times we are not able to take a decision. Reason being, we do not have a sufficient knowledge or inadequate or imprecise scientific models. So if we do not have a precise knowledge, still we have to make a decision, ANN will be useful. So what we say here, these decisions are earlier conclusions were hindered because of inadequate and imprecise scientific model or knowledge, and sometimes we do have a missing data or having incorrect data also, right? So ANN tries to find out the patterns and the correlation within the data. So this is important, so that's why I have given this reference. Paper has described slightly in better manner. Now I'm continuing the same paper, what they have mentioned here. There is a artificial neuron or a node, what we mentioned. Same thing has been mentioned, x1, x2 and x3 as an input, weight factor w1, w2, w3, and there they are providing activation function. So what we see in this case, they have described the neuron as a fundamental unit of a artificial neural network, and then it provides the input signals, incoming signals, which is multiplied with the weights. Now here we are using the word alter because the neural network time, every time this weight will be changed, which is to some extent good as well as a bad. In one go we get some sort of the weight factor, and next go whole weight factor can change completely. So we may, instead of approaching the solution, we may move away from a solution. So that's why we really require algorithm to be robust. It provides the right direction. That's why many times we use the word adaptive learning instead of the learning maybe say 0.01% or 0.1% or 1%. It should be continuously changing depending on how the response is being given to the signal, or maybe say inputs. Once it is done, they have subsequently summed up, and then they are subjected to the activation function. Most of the time we use a sigmoid as an activation function, which we have already learned in the previous one of the lecture or 24th lecture. We say we use a sigmoid for the classification. We say that sigmoid provides a value of 0 or 1, and that has been given. We took example of the gender height female and male, and we say it may be the top one may be treated as a one gender, and 0 should be treated as a second gender, and that's why we use a sigmoid number. However, sigmoid can give continuous value from 0 to 1, and that's what we are requiring here. And you can see here this function is not a linear function, it's a non-linear. So that's why we want to bring some sort of non-linearity in a relation, and that's why we are using a sigmoid function. Now one more thing comes here, what we use the word a shallow network. Shallow network is a often is a one hidden layer, and deep network comes with more than one layer. Of course, in these days when we are talking of 100 layers, 200 layers, people feel even the 5 layer is a shallow layer or a network. It is just a subjective. In my view, more than one hidden layer, it should be treated as a deep network. Now in this case you can see there are 4 inputs. There are input layer that has been shown, hidden layer which will be processing, and output layer it has a 2 output. It can be 1 output, can be 2 output, but what is an algorithm name has been given? It says a feed forward architecture. Now it's a concept and it may not give good results. Reason being, it lacks a feedback connection, because we need to know that how initially we will not be knowing what are the weighting factors. So we guess it can be 0, it can be 1, it can be in decimal 0.01, something like that, but we need to iterate. We do iteration based on what is the feedback. Now we x1 to x4 are being given, y and y2 y3 have been also given to us. In between whatever we are doing, that is not given to us, so it has to be calculated, estimated, iterate, so that overall finally we are able to get a good relation between x1, x2, x3, x4 and y1, y2. So these are the things, and here mostly we assume inputs are independent, they are not dependent in many of the algorithm. However, neural network doesn't give that kind of imposition that it has to be all independent, but if they are independent, that will give better results. So this is what we call the shallow layer, and then here we are talking about feedback architecture. You can see here that every feedback is written back and given provided information to the system, and this is important to correct the results. If the feedback is not being given, then we will not be able to improve the results, and then as a feed forward, as I mentioned, it may not be able to help the correct answers, may not be able to get a convergence properly. Now coming to the MATLAB, we have a number of deep network designers. Maybe it has a designer as a one of the tool you can design, and they have a number of already designed in the networks, or we can also design our own the way we want it. These are generally used for the image, which is many layers, and the image networks generally are many layers, which has been shown. When you click, you are able to see number of layers in that. You can really delete or add which whatever you required. So that's why we say deep neural network, which is a DNN, and then sometimes we use a CNN, a convolution neural network. So we have many other algorithms are also available. So we can design any algorithm, we can use any algorithm, and then we directly give input and try to find out output. More details are also given on this link, which has been given here. It is a MATLAB link, because they are providing these algorithms. I am just taking just click on one of the example of the GoogleNet. GoogleNet has also provided a pre-trained network, how they try to analyze the various objects and then come up with the right results. If you look at that, they are using number of layers, 944 layers, which is significantly higher. We may not require this many layers as per my knowledge. In Travelodgy, we require 4-5 layers at most, and that we get a good answer for that purpose. Now as a same deep network designer, in this case we can generate our own code. That's what it says, that create a deep learning network architecture, create the graph layers, and then you can export complete algorithm in your workspace. You can change that algorithm, you can delete, you can add layers. So not necessary whatever the algorithm are available, only we need to stick to that only. we can export and necessary changes can be made on that. So that's why it is stated really clearly the generate MATLAB code for to recreate the network. That's also possible. We can learn because there are already number of networks are already available and algorithms are already available. We can learn how do we do a proper modeling and get a good results from that. One important thing about a deep neural network is that the training as well as the validation. While in this case it has been shown here the training as well as a validation. So this black line has been shown as a validation, this has been shown as a training. Now this is related to accuracy, this is related to the losses. We need to minimize the loss, we need to maximize the accuracy. You can see here, and after 450 iteration they are getting very good results, almost 97.5% accuracy. Whenever we do iterations, then we need to check the accuracy or we need to check the losses, and then we will be discussing these two aspects in the present lecture. This is important. More details are also being given on this the link, which says that the deep learning help references and the train network has also been given over here. Now coming to the present topic, we said the deep neural network in tribology is really important. Yes, reason being the many things are not known to us at a micro level, many things are not available to us at nano level. So we really require, and we do not have an exact governing equation available. There are equations, we should take that utilize those equations, we draw necessary knowledge from those equations. However, we know very well that most of the results have been quoted in the books and the literature based on experiments. So often people say that tribology is experimental tribology. It's not a theoretical tribology. So that's why we are trying to bring this machine learning. And then we also have learned something like experimental design, because we can't do it with so many experiments. So that's why we use Taguchi and ANOVA. Reason being to reduce the number of variables which we require. However, in lecture 19 we also learned something like there are limitations of Taguchi and ANOVA, and that's why we require this kind of machine learning algorithm which has some more flexibility compared to the Taguchi. That is what was highlighted in lecture 19. I'll take one example also on that. Now when we are talking about the deep neural network, naturally there will be hidden layers, 2 layer, 3 layer, 4 layers, and then there be input parameters. Input parameter can be a material composition, it can be lubricant composition when we are synthesizing lubricant, or we are making some sort of composite or changing the characteristics of the material. So these are the inputs. We may require a mechanical or rheological property. Rheological property maybe the polymers, plastic, or maybe say the liquid lubricant, greases. Those properties will be required. So these are the inputs. Then we have in the recent maybe lectures we learned that surface plays a very important role compared to other parameters. So if the surface parameters are also given as an input, that will give a good results to us. Now we can use testing condition is something like operating temperature or speed, load parameter, that can also be given as a input parameters. What is really output which we are estimating, which we can measure, is that we can measure the wear volume, wear rate, depends on the whatever available to us. We can measure the coefficient of friction, friction torque, or maybe even operating temperature, flush temperature, or maybe say liquid lubricant temperature, film thickness, vibration signals. Those things can be utilized as an output. And then we need to really use a back propagation algorithm, which we need to calculate error at each iteration, and then use that error as a guidance mechanism for the improvement in a weighting factor and biases. So this is what is really required for our purpose. Just to understand, just to elaborate what I said and what we are trying to achieve, I'm just taking one reference paper which was published in 2020, and what they aimed or they were designing is same thing what we have been discussing in this course. They use a design of experiments with Taguchi method, and they can try to connect a neural network with a Taguchi method. They perform experiments particularly dry sliding adhesive wear, that means lubricant is missing. They use a Taguchi L25 orthogonal array. Test parameter, they use a sliding velocity, sliding distance, normal load and filler content. Basically they were making composites, and trying to use a marble dust as a filler in that matrix. So what we know, they use a 5 levels. This is the level 1, like in this case sliding speed 25 centimeter per second, 50 is a second level, 75 third level, 100 fourth level, 125 fifth level. So they were using 5 levels, 4 factors, as I say, sliding velocity, sliding distance. They are going to use a 5 levels, 250, 500, 750, 1000 and 1250. They use the 5 loads, 5, 10, 15, 20, 25 Newton. They use also the 5 the compositions or filler content, 0%, 8%, 16, 24, 32%. So they have used these 4 factors. Now we know that overall number of experiment or full factorial design requires a 5 to power 4, which means 625 experiments were supposed to be done. For the complete analysis, they performed 25 experiments, which is good. So they have reduced substantially number of levels. Now question comes, how do we interpret? How do we really come up with a conclusion? What is being given? So whatever we have done ANOVA in lecture 19, I am going to repeat the same thing. So there is a factor 1, there is a factor 2, factor 3, factor 4, and whatever the specific where related results have been given quoted, what I will do for factor 1, I will combine all levels, then I will take a mean value, average value, and then based on that we will find out what is the contribution of factor 1 in a specific wear rate, what is the contribution of the factor 2 in a specific wear rate, what is the contribution of factor 3, what is the contribution of factor 4. What is the advantage to figure out whether this Taguchi had a sufficient knowledge, whatever the method which has been utilized providing sufficient knowledge or lacking something, and we really require ANN for that purpose. So let us see factor 1, level 1 has been given all the results, level 2, level 3, level 4, level 5, and overall contribution using the same thing can be provided over here. This is says that contribution is 5%, contribution 2.46%, contribution 4.1%, and contribution 78.07%. Of course, we are using the word error also, which has a contribution roughly 10.3%. So what are the results? Factor 1 provides a 5% contribution, factor 2 provides a 2.5% contribution, factor 3 provides a 4% contribution, factor 4 provides a 78% contribution, and there are errors because we are not able to analyze all interactions, because we really require more number of columns, because degree of freedom 4 has been consumed in this, degree of 4 in this figure, degree of 4 in this, degree of 4 in this. So 16 degree of freedoms are being consumed. We have only 8 degree of freedom which can be utilized for analyzing other results. For time being, we are using an error because we can figure out only 1 or 2 interaction, but not more than that. If we, so whatever we showed in lecture 19, there are drawbacks of Taguchi and ANOVA. Same drawbacks have come in this one also, but little more knowledge because we have learned many things. We also have learned that from lecture 3 that where can be represented as a Orchard equation. Of course, it is only a kind of relation which is does not have a completeness, it may be different, but in that lecture we learn that where is proportional to applied load. If you increase applied load, wear rate will increase or wear volume will increase. If you increase the sliding distance at L, wear volume will increase. If you increase the hardness, wear volume will decrease. Now, if you try to connect with this relation, lecture 3 relation with this data which are available in literature, what we are able to see as the sliding velocity is increasing, wear rate is increasing, which is not there available in this literature which we have taken. Second thing is available, if the distance is increasing, sliding distance is increasing, wear rate is initially increasing, then decreasing, then increasing, and again decreasing. So that is also not matching this relation. Now next one is a normal load. As a normal load increases from one level to 5 level, the wear volume rate is increasing. Coming to the filler content, so this normal load has been shown somewhere, maybe it is not maybe 100% linear, but looks like yeah, it is giving some results. Coming to the filler content, which says that if your number of filler contents are increasing, wear rate is coming down. so which is also not available over here. So how do we analyze results? We say now, as per our knowledge, distance is given as a velocity into time. That means either in this case, either I should choose a distance as an impacting parameter or velocity as an impacting parameter. I cannot choose both. So one of the what I am able to see, there are these two factors are completely interdependent with each other. They are not, maybe say, separate factors. Velocity completely depends on the distance, distance completely depends on the velocity. So these are not two independent parameters. So whenever we go for Taguchi method or we go for ANOVA, first thing is that parameters should be independent. If I am bringing a lot of dependence between these two parameters and trying to do some experiments, I will not achieve very good results. So that is what the first thing comes. Second thing, what we have learned in lecture 5 about that when we say parameters, we use RPM, maybe the like a sliding velocity, and then contact load and time duration. That means if instead of this distance, if they would have used time duration, time span, then it would have been slightly better. So what is the number of the minutes they have operated or number of seconds this setup was operated, then it makes a somewhat good solution to us. So in my view, this distance, which is also showing some sort of irregularity in a behavior, may not be treated as a factor. Instead of that, we should treat this as a time as a one of the factor. So this is a learning. When next time we do this kind of experiments or somebody does, they should consider that whether parameters are independent from each other or not. So when we are using the word main effect of other where, this is not a main effect. Either I should consider velocity or should I consider the sliding distance. It cannot be both as a main factor. So this is what we say when we have a literature or when we have learned something on tribology, we are able to interpret on the results. If we don't have this domain knowledge, then all the day everything will be like a number and I will be getting some conclusion which have no meaning at all. So which is not correct in this situation. And one more thing, now here we are using the word filler content. So question comes, with the filler contents are really playing a role to increase the hardness? If it is, then it should have been quoted. If it is not, then again the factor should mention the what remain a hardness, whether hardness remain a consistent, constant or not, because this is a one of the very strong variable. It is not that can be neglected. Neglecting this factor is incorrect. So whatever the important factor, they should be counted. If we are not counting, that means naturally we will not be able to get a very good clean results. So whenever we next time do some sort of literature or maybe you are trying to explore the data, extract the data, we need to consider what we have learned in a tribology and how do we interpret the results in appropriate manner. Now, as I mentioned, from my point of view, sliding velocity is okay, and sliding distance is already showing irregular results, may not required. So maybe next comes the load and then comes the filler content. Again, I am using the word, when we are using the word filler content, again maybe we need to also see whether hardness remains same or not. If it is not, then we need to check and why this parameter was not considered or taught. Now, if we say that we can really use the word time, or if we make a parameter time instead of the sliding distance, it may provide a slightly better results. So let's see that. Now if I am using the word time, now here what is the relation? Simple, b in centimeters. That means what we say, the 2250 into 100, then you divide by this velocity, it should give me that time. That's a what, 1000 seconds, that should come over here. So I'm using that relation, b in centimeter, not in meter, and a we are dividing with a. So that column, so 1000, 2000, 3000, 4000. So we are just interpreting the results what is already there. We are trying to figure out whether we can use data in more meaningful manner. However, this is done, then 500, 1000, 12, 1500, 2000. So these other factors can come directly. This is a simple b in centimeter divided by a relation. So are we getting some meaningful results? No, there is a problem. Reason being, we are not able to get a 5 levels because all experiments were done under 5 levels. Here we are getting 5 levels, but then 500 is a 6th level, then 1500 is 7th level, then 2500 is 8th level, then 333 is a 9th level. We are not getting any repetition. Taguchi has a strength so that we get a repetitive experiment. The 5 and 4 factors something, the 5 levels, we can average, we can take a mean value. That's a usefulness. But here we are getting almost 19 level out of 25, only 6 experiments have a repetition, other experiments are different. So we cannot get a really reliable results. Now one more factor, they have quoted as a specific wear rate. Now when they have written a specific wear rate as a one parameter, major issue comes. They are already using a relation. They measured the mass. What is the mass loss? Delta m. But they are assuming density. Density is fixed. Now question comes, will the density be remaining fixed when they are changing the filler content? Means 0% filler, density is a 1, whatever the x unit. Then if I go with the filler, 8% density remains same, or 16% density remains same. So this is another issue. Here where we are already using the derived relation, then there is a possibility of errors. Then another thing, they are also using the load. They are also using the sliding distance. So they are not independent. Again, a specific wear rate becomes a dependent. Whatever the load and whatever the sliding distance, we are incorporating in this. So again, we are making a lot of dependence. One more thing, when we are measuring the accuracy, accuracy is a 1 milligram plus minus 1 milligram. That means error will be up to 2 milligram. When they are using this relation, which is very sensitive, that means accuracy of the measurement need to be improved. So these are the important findings. Whenever we try to extract the data from literature, we need to figure out how the things have been done, whether ASTM standard have been followed. If it is not, then how do we interpret the results? Are results more meaningful, useful? If it is not, then we need to move to the next paper, next paper, next paper, next book, so that we get at least some meaningful data from a literature so we can interpret. Often people are confused with that. They read abstract and conclusion and then they say, oh, author have said this one. Author may have said it, maybe based on his understanding or her understanding, but here we are trying to build a course or build a knowledge domain that can only come when we are trying to analyze each and everything in appropriate manner. Now let's see, assuming data have been provided and we want to use a MATLAB for that, because MATLAB has so many algorithms, quite possible all the noisy signals also may get a good results overall. So we done that, we use a regression analysis. Of course we can use a neural net fitting also, both the things are possible, but I found the regression learner has a many other algorithms, so the comparison will be easier. So when you do that regression and then try to open a new session and try to get the data which are already available in this paper. So whatever the data available in the paper, I am just using as it is those data. When we do this one, then it is asking whether this in the 4 data, there is a sliding velocity, sliding distance, normal load, filler content will be treated as input. Now here, if I assume the sliding distance is the incorrect input, I may have removed also. There is a possibility. That means now here the more choice comes when we are using the MATLAB. We can eliminate one factor and we say, okay, interpret the results with a, but question comes whether removal of that factor will make any good sense or not. So for time being, I am using as it is all the factors, and then we are going for the cross validation 5 times, and then we are also using the 20% data set for the testing purpose. So when you do this, finally another option comes whether you want a PCA to be enabling. If you are enabling the PCA, you can really see the percentage of each. Whatever we have done from ANOVA, where we got a 78% contribution from a filler content, that same thing can come in this case. That means if we have this neural network or maybe the regression learner, we may completely avoid the Taguchi or completely remove the ANOVA. Same interpretation come directly using by enabling the PCA. I get the same response in this directly. So that is done. If you don't choose any algorithm, by default this MATLAB chooses a decision tree as a one of the algorithm. However, in this case I tried also with a linear regression, whether the linear regression is possible. We can go ahead with the robust options on and then try to get the results. You can see here decision tree, which is by default what MATLAB takes, and linear regression we are getting something like MSE, very good values. This is another problem I have found in literature. Most of the time when neural network have been utilized, people are quoting only MSC value or MSC value, but they are not quoting R squared value. So that is one of the point whether really R squared value is required or not. For time being, I am using R squared value is required because we are using regression analysis. We are trying to build the relation. Whenever we are trying to build a relation, R squared value must be required. However, if you want going for the classification, we want to keep some sort of a bins and then put the one class, other class, third class. That may not be R squared may not be required. We are not developing, establishing the complete relation as such. So, however, in this case, I will give importance to also to the R squared. However, I also found that most of the neural network option, they do not have R square option. They are calculating, they are using, but they are not using for the convergence purpose. They use MSE as a convergence purpose. So we always get a very good result for MSE. One more thing is that when you use a MATLAB, you can choose all algorithm. You say, okay, you select all and give me the comparison. So that has been shown here that many algorithm have been selected in neural network, neural network, neural network. It can be all three options, maybe narrow, maybe medium, and maybe white. All three option. Then it has three trees. It a linear regression. It has a efficient, maybe say the optimization method also been utilized. And what we get on the R squared, we see if you look at that MSC, everywhere MSE is been given as a convergence criteria. It is giving very good results. While coming to R squared value, we find very odd value like in a network. It is gives a minus 65, minus 0, minus 0.72. So this is a one very different, and if we require both, then we need to mention that this is an important feature and need to embed in algorithm. Maybe we can export the neural network algorithm from MATLAB in our own workspace and then modify and include R square values in that. Or we give a R squared value as a one of the convergence criteria. For timing, I am not able to find out that as a one of the convergence criteria. That's why all the results are very different, even though everything has been converged. So this is what we realize, and it needs to be accounted appropriately. And as I mentioned, you can use enable the PCA if you want to remove one parameter or two parameters, up to you, and then we get more results. Now question comes when we are moving from this ANOVA to neural network, what are the things? As I say, ANOVA assumes a linear relations. ANN, we are using sigmoid function or some other function, tan hyperbolic function, or so we are able to bring some sort of non-linearity. So non-linear interaction is important. And then as I mentioned very clearly, when we found a dependency, it will not be able to give very good results. However, to this ANN, even some dependency, that will also be captured appropriately. And then we say that like a friction, a continuously variation will come. Nothing is a deterministic, it will not be set by the rules, so it can be changed also. So that's why the ANN will provide a better results. How to implement whatever we explored, we were covering one example where we say the sliding velocity input, sliding distance input, normal load input, filler content input, and the 4 inputs, and then we want to use ANN appropriately. And in this case I am using the 10 the neurons, assuming n into n plus 1 divided by 2 as a criteria, that for input we can use this formula whether it will give me the good results, and only the one is output. We will be trying to utilize back propagation error steps also, because feed forward will not give all the results. So we really required error calculation. For error calculation, again we need to use some sort of differential mechanism, or maybe say method like a descent method, gradient method. So otherwise it will not be able to give a right results to us. Right now, when we use a inbuilt algorithm of the MATLAB, you can see here RMSE value or MSE value. That's what a convergence criteria was given. MSE gives a very good results immediately, and then however R validation, as I say, inbuilt algorithm is not there, or maybe the convergence criteria is not there. So that's why we are getting sometime 0.43, some 0.5, 0.58. So when we need to really give as a one of the algorithm or one of the convergence criteria for that purpose. So this is a basically 3-layer neural network which we utilize. Of course, input parameters, we tried different things, and most good results came from first layer, second layer, third layer. When we give 8 as a first layer, 10 neuron second layer, 8 neuron third layer, that gives a best result to us whatever we tried. And this is what, as I mentioned, we can export this to our workspace and build our own algorithm that may provide a better results compared to what is already inbuilt in that. For that purpose, we can develop our own algorithm. What has been shown here, there are 4 parameters. If I take this is a 10 n plus n into n plus 1 divided by 2. So one we are this z1 to z10, and then we are taking a weighted summation of input variables plus bias. We are using the sigmoid function for that purpose, and finally we are getting output results, and this output results need to be compared with the given results. Here we are using the activation function also. It can be sigmoid activation function, or it can be linear function. As I said earlier, sigmoid gives a 0 to 1 results, and moreover the derivatives also is possible. You can see the derivative value which is shown in the green color line, that has been shown here. And coming to the output layer, we use a rectified linear unit. Most of the time people have used the outer layer as a last layer as a value function, obviously the rectified linear unit when they have used. So we use this kind of relation. So you can see here by proposition, and then wherever output need to be differentiated, and then even and then this because we need to vary the weight factors and bias factor. So naturally whatever you want to vary, you need to differentiate with that. So if you want to really update the weight factor, naturally whatever the results are coming out, we need to differentiate with respect to weight factor and bias factors. Now when there is also hidden, so we again we require this. In this overall we need to update all the weight factors. Now weight factor, when updation is coming, that we are using also the learning rate. Learning rate is a eta. It can be 0.01, 0.1, or maybe 0.001, depends on the how the convergence is fast, getting moving in the right direction. Sometimes people can use adaptive learning algorithm, or maybe say adaptive learning rate. It can start from 0.1. If the convergence is going much faster, then it can slightly reduce, or it is going to away from the real results, then it is again reduced significantly. So that's possible how based on the consecutive 4-5 results we can change this learning rate. Now we use a MATLAB code and then try to generate, as I say, the read the data. Then we are taking the input and output, whatever the table I showed, that we are using the thing. So data on the column, there's a 1 to 4 is the input feature is saved, and the 5th column we saved as the output feature. We do a normalization. Now normalization is sometime required. Some people say that neural network doesn't require a normalization. However, in my view, normalization is a must. And then MATLAB has a normalization algorithm also, where the mean is 0 and the standard deviation is a 1. This is the same thing which we have used in PCA. We do a normalization first, that's a must essential, and that's why we have done the same thing in this case. After that we are trying to provide 25 data. In that 70% is a training. So that's why we are using, as I say, that MATLAB has inbuilt algorithm partition, and then based on this directly we are using those things. And even though we are not able to point out properly, like instead of 70% I should have given 72%, but MATLAB has algorithm, so it means instead of the 17.5 data they convert to 18 data. That's what has been shown, because if you take a 25 75% 70%, it will give 17 and a half, which is not correct in this case. So that's why we are getting observations are 25 which we have given, and the train size is 18, and then test size will be 7. So it is done automatically. Rounding off it does by MATLAB algorithm. Now we do a normalization and we want to check what is really the results after the normalization. So this the left hand side results are before normalization and right hand side results are after normalization. As I mentioned that that 0 square which we use, we has a value mean as a 0 and the standard deviation equal to 1. This is what they utilize. Now these are the data which will be provided or maybe will be processed, so that overall the wear rate can be calculated or specified wear rate can be calculated. Then we are dividing into the training. This also we are trying to check whatever we algorithm we are giving, it is really correct, doing a right printing or not, and then whatever remaining thing, this is will be used for the testing purpose. And however, in the first time when we are trying to iterate, and then we find very clearly that when we are doing iteration, first data may be the same, but second data is changing, third data is changing, fourth data is changing. That means we really require a rigorous iterations. One or two go, we are not going to get a results, and really we require this kind of iteration. That's why we use epochs, and we say max epochs. We kept max epochs as a 1000 to try to find out the results. And then MSC has been MSC threshold has been given in this case as a one of the criteria, but we can include R square. For timing, initially we wanted to test only that MSC, so thus we wanted to compare the results. We tested, and then here finally we made a 15% as a validation data and a test 15%, and we found that the validation takes 3 to 4 data and the 4 data and test take 3 data. Overall results gets converged with the MSC value. That's the MSC value you can see here. MSC validation and testing, all results are very good in this case. Of course, in this case training has been made a 17, the next iteration we made, and then it became a 17, and the validation 4 and testing 4. However, you can see here the training R square value is good, but subsequently validation did reduce and testing it has reduced, and we have not given as a convergence criteria. So next when we develop algorithm, we need to give as a one of the convergence criteria, that if the R square need to be more than 0.9, then only the convergence happen, otherwise it should not happen, because we want the results to be predicted appropriately, accurately. So this is very important for us. One more thing I have learned also in this experiment, that when we go for optimization, we must use a random search method compared to the descent gradient method. So this is what was done. However, I learned more thing, whatever the data we got from a literature, for that other method is giving far better results. So that's why we use a Gaussian process regression method. If you look at the RMSE value is a 0.0040931, that's a very good results. And if you look at R square value also, it comes a 0.94. So again, not whatever the literature we are doing, not necessary that we get a good results for only neural network algorithm. There are other algorithm in a MATLAB which are providing better results than the neural network also. So we need to explore all. One more, as I mentioned, that we need to use optimization algorithms. If MATLAB inbuilt optimization algorithm can be utilized, it will be giving them better results. My understanding is the random search is giving better results. With this, I say thank you for attention. Thank you for this lecture.